It is definitely not a regional problem. It is a global problem.
There's got to be a better way. There's got to be a different approach.
After you've created that much material, where does it go? And our oceans, our environment, landfills, incinerated up to the air, those aren't acceptable options.
We are a manufacturer, we make materials, therefore it is incumbent upon us to be part of the solution.
The world is expecting us to deliver.
We've got to come up with a better answer. And then it's going to take companies like Eastman that are willing to step out and make early investment and to show the world what's possible. And it's going to take people like Bruce DeBruin.
He's really the perfect combination of scientist and just a practical everyman.
He was the plant manager for the original polyester recycling plant that was in Rochester, New York, and is one of the key inventors on the redesign that we are getting ready to install here in Kingsport.
The process was first developed at Eastman Kodak Company in the 70s. The original process was a methanolysis process, and it was to break down plastic back into its raw materials to do molecular recycling so that we would have raw material to run the plant.
What started out as X-ray films expanded into a lot of different types of plastic as the engineers made it more robust.
Over the years in that process, we chose to switch out equipment, to use different processes, to come up with different ways to get that higher purity with lower energy costs, and lower energy costs is better LCA.
We spent 40 years learning to do it. Didn't start out easy. Took upwards of a decade to get pretty good at it, honestly. That heritage has given us this opportunity today to build upon this quickly, to show the world what's possible, to give them the opportunity to choose what's right for the planet and choose it right now.
We want to believe that that material that we're dropping in a recycle bin somewhere is absolutely getting converted into a new material somewhere, and that it doesn't somehow find its way to a landfill or incinerated or even worse, to a waterway. You know, the numbers are staggering.
In a mechanical recycling process, essentially the materials are collected, they're separated by type, and there are different businesses that will purchase those and they will reclaim them. It's a fairly simple process, but to do that requires pretty high quality materials.
Even the most recycled plastics, even with PET, not everything can get back into a circular economy. Most PET can't get from a bottle back to a bottle. Most of that is going to be downcycled into films and fibers and things that can't get back to that bottle. So it takes technology to do that.
Rather than, that take, make, waste linear economy that we've had before, the circular economy is served by being able to bring a technology to market that allows us to unlock those value that's still in the material.
A big part of what we're trying to do is today you think about plastic waste as waste. With a new ecosystem, with new processes, waste can be seen as something different. Waste can be seen as raw material with value. Once something has value, people are going to treat it differently.
In molecular recycling, we take a material and we break it back down to its building blocks.
We take the waste streams, we take the streams that nobody else wants.
We're targeting the hard to recycle waste. How can we make that new again? We're using a process with methanol and catalysts to break plastic down into just one step below plastic. From polymer to monomer. The farther you have to go back down into a basic feedstock, the more energy is to go this way, and the more energy is to come back up.
By going back just that one step, we can get a process that has, 1,000,000 to 1, 1,000,000,000 to 1 refinement of impurities and components in that system.
One key advantage that molecular recycling brings to the table is the ability to repeat the process over and over. So you can essentially create a nearly infinite loop.
This can happen again and again and again. This is not about one time and it's done. This is about as many times as you can bring it back, you can use it again.
I think this technology proves that that is a future we can count on. It's not just an aspiration. It's not a pipe dream that's so far in the future.
This isn't something that's 5 years out, 10 years out. This is something we've known how to do before. We're doing it.
The proof points are there. Our customers like what they see. They are signing up to purchase materials that contain the recycled content. I'm very optimistic that we're going to be successful.
We've got, a 40-plus year track record where this technology has already been proven. The kinks have been worked out, and so it's available today and can be scaled up.
We're constructing a plant that will have the ability to take 110,000 metric tons of plastic waste that would be destined for landfill and make it brand new again.
This is one of the most exciting things that I have worked on in my 22 years at Eastman. We have teams in Europe, we have teams in the US, all working together on how do we scale our processes faster. Everybody at the company has completely bought into this is our future, that we are going to make a difference globally as we continue to scale these processes.
It is a global solution to a global problem. So we want every country to be recycling all their plastic back into plastic.
We feel very confident that the asset we're putting in the ground today will use that technology, build upon that history, divert material from landfill, leave fossil feedstock in the ground, and do it at a lower carbon footprint than you can make virgin product out of. Doing things differently, it's not easy. I mean, it takes capital, it takes risk, it takes being willing to change the status quo and being willing to be the one that's doing something that nobody else is doing. We have this unique opportunity, almost a responsibility, to be a catalyst, to show the world what's possible.